All right, looks like we have pretty much everyone. Okay, so my name is Matthew Mosesohn. This is Antoine Legrand. Before I start getting into Kubespray, let me ask first, who here has already deployed their own Kubernetes cluster? Raise your hand. Pretty much everyone. Has it been multi-node? Everyone. Multi-master? That's cool. That's exciting. So I wasn't expecting it. People are like, I've never installed Kubernetes. Let's get an intro. So this is kind of a basic talk, but we will have time for questions at the end if you want to have any questions about some things that might be kind of deep, but maybe we won't go too deep. I'm Matthew Mosesohn. I work at Virtustream. We do kind of a storage and virtualization platform on top of Kubernetes. Kind of everything end-to-end inside in Helm charts running on Kubernetes. It's very exciting. Antoine founded.
Yeah, 3 years ago with Smain for our own production use case. And I'm also very interested in the application deployment, how to manage your workload. So working on the app definition and also monitoring team inside OpenShift.
Mm-hmm.
Good, good.
It's yours.
Yeah, so why we care about like how we deploy Kubernetes. So we go to the end goal is like to run application and to keep them running, to have them highly available. So this go down to the cluster infrastructure. So when you upgrade your cluster, you need to make sure your application keep running, etc. So this is like just to refresh why we care about the infrastructure. So to make sure your applications still get resources and be able to run in a highly available fashion.
So Kubernetes, deploying it seems kind of easy if you have a script that does it all, but really you need to think about what are the building blocks of a Kubernetes cluster. There's master nodes, there's node nodes, because slave isn't a cool term anymore. There's etcd, which is commonly combined with the master, but it's usually kept separate in case of scale deployments, over 100 nodes. You need a container runtime, which is usually Docker. Network plugins, if you have multi-node, you need CNI. There's other ways, but most people use CNI. A way to make your certificates for the Kubernetes API and for etcd, unless you don't care about security, which shame on you. And persistent storage, if you want your containers to keep their data after node restarts or migrating, you really need persistent storage, which is usually offered by your cloud vendor or something you can deploy yourself, like Gluster, Ceph, and Rook, whatever you want. This is a really not ideal diagram, but just kind of an idea of how Kubernetes deploys. There's masters, and then there's the nodes. And everything routes through the Kubernetes API server, not the controller manager, as it seems. So the API server talks to etcd directly. The nodes talk directly to API server. The other master components route through the API server. It's just like a client server architecture. But so a lot of people ask, why do I work on a Kubernetes deployer? Isn't it really easy? Well, it's not. And why is it divisive? So there's the old argument of which configuration management platform is the best. I kind of picked Ansible for a few reasons, but there's others out there. Or should you go alone and make your own? Or should you orchestrate with something written natively in Golang? That's just a topic that brings a lot of contention. And then there's, of course, the not invented here syndrome, where people are concerned, if I didn't write it from scratch myself, how can I trust it? So a lot of people are still going to write their own. A lot of vendors are going to write their own because then they can put their name on it and sell it and offer support. Kubespray, it has no commercial support. It's just an open source project in the Kubernetes ecosystem that's not official, but it's in the ecosystem. And of course, deployment is divisive because people want their deployments to be reliable, reproducible, and maintainable. So that's another reason some people prefer to deploy their own homebrew. The other items we compare ourselves to, our peers, if you would be KOps or COPS, which is written purely in Golang. It's a very good piece of software. It happens to be geared more towards Amazon Cloud, so AWS, and it has offerings for bare metal. We kind of differ ourselves in that it's deploy everywhere, including other clouds or bare metal or virtual machines and so on. There's kubeadm, which is very popular, very official, but it has some shortcomings because it doesn't prepare your nodes completely for deployment. So we do have a mode of deploying Kubespray with kubeadm, but it's just a small part of the deployment, actually. And then, of course, there's commercial offerings, which are either open or closed source. They have their ups and downs, the down maybe being cost and openness. We try not to compare ourselves too much with them, but they do exist, and we coexist with them because people will consider them.
Yeah. So Kubespray, quickly on the goal. So it's a cluster lifecycle manager. So it means like to create your cluster, but also after how to manage it. So how to upgrade from Kubernetes 1.9 to 1.10, but also how to add nodes, how to downscale, scale. So really thinking about the management, which is like creating cluster, it's fairly easy, but then being able to upgrade them can be more complex. One of the initial goal was like production ready. I say was like for our own use case, so deploy Kubernetes production setup, so highly available. This is like a key goal, so a lot of work in it. And flexible and composable, meaning to work on many OS, to be able to choose a network plugin, to acknowledge like there is a lot of components in the ecosystem that we can just change. So this is like one part we've been focused. And yeah, the project has nearly 3 years now, and I've always been committee driven. So there is like no one shop behind, and yeah, just the committee driving the project. Okay, so we choose to use, so Kubespray is an Ansible playbook. We choose Ansible because first it covers all components. So we can just have like a plain operating system, just with the SSH access, and just set up it from scratch. That's a very key element. Ansible is very easy to read, even for people who don't understand. It's very easy to follow. So there's like many users in the community never known about Ansible before, but just be able to copy the playbook and get started very quickly. So as said, it's flexible, it works on many OS, and it's actively maintained by the committee and Red Hat now. So
yeah, thanks, Red Hat. They've added a lot of useful modules since the acquisition, so the project keeps getting better, which is a good sign if it's something you intend to be invested in for a while. Nobody wants to deploy a production cluster that has its software go out of date quickly. So in addition to just being Ansible-based, we have a strong focus on cross-platform. You can have heterogeneous OSs across your cluster, preferably same Docker version. You might have interesting results if you try to mix. We do containerize everything, the static pods for the master components, containerized etcd, and some other services. There's no packages that are installed except for Python dependencies for Ansible and Docker, which is nice. So that makes the cross distro compatibility layer quite easy. We just added SUSE support a few weeks ago with no issues. The only thing was installing Docker. So yeah, bring any OS or bring any Linux flavor in that we have bindings for, and it should just work. We do have a compatibility matrix. I won't iterate everything here. I'll also list that we have 3 different modes for generating certificates. Our own script-based, which just runs OpenSSL, X509, create, very boring traditional approach. There's the kubeidium approach, which does this all in Golang, but basically the same. And then we have HashiCorp Vault support as well, which stands up vaults, and then you can hook up Kubernetes back into the vault so that all the secrets come out of vault as well. It's quite exciting stuff.
Just to reflect, also this compatibility matrix is why Kubespray is being like highly adopted, because it just like fit whatever your infrastructure is. It's mostly going to be able to work on it. Like we don't ask you to change for any particular OS or any particular setup or cloud. It's just like mostly going to work with your actual infrastructure, which is a good thing.
We're not biased about network plugins. These are just the ones that we have configuration for. We've added more. Recently, Contiv just was recently added, so there's room for more if you happen to work actively on a network plugin. What is going on? Okay. Cool. It's a clicker. I think I have to click. Okay.
Yeah, so I say it's the project have been like driving by the community. I think the community grew like twice in the last few months, and it's very supportive. Like mostly newcomers just say, "Oh, I can." People always help on the Slack channel, so you can join the Kubernetes Kubespray channel, and you get like ton of help. There's like more than now 240 contributors, which is a lot, and means it's very easy to just. Many people just do one PR, and sometimes they are big, but it's very easy to get started, like to add your own use case and just fix a bug. So thank you if there is a contributor in the room, because this is like how the project move forward. So this is like just quickly also to thank you companies and contributors who just continue to contribute. So yeah, some of them.
Yeah, some of these companies don't work on Kubespray as their main project, but they have members that work on it for some smaller projects. But this is just a representation of people who have worked on the project. So really, it's diverse. It's not any just one company that's dominating the project. We do run continuous integration. We do only 3 full deployment scenarios by default, just because of time constraints and cloud credit constraints. But before release, we do run all 20-plus CI cases, because we have so many options and configurations, and if we didn't test them all, we might miss bugs. So we definitely need to run all these scenarios, but we do make sure they all work, which is good for users, rather than saying, oh, it passes some sort of syntax check, I'm sure it works. No, it's really tested. It's used in production in many companies already. The CI test is a good way to enable first-time developers to see if their code actually works without having to maybe test it locally, but that's not actually really good.
This was like one of the question, like the compatibility matrix, like how you can be able to maintain such a huge different paths was like one of the comment feedback, and this is like why we focus so much on the continuous integration. So we're sure, like we try with Rocket, we try with SUSE, and someone changed on Red Hat, we just trigger the change for the Red Hat OS, etc. So this is really how we can move forward quickly, because we have like many paths tested.
This is a really busy slide. Just all the main steps we go through for deployment. We have to prepare the OS, get Python on there if it needs it. A lot of cloud images these days are very small, so that they boot up faster or can be pulled down faster. Then there's some pre-install steps. Maybe set time zone, maybe create some directories, verify cloud config parameters, and then we set up Docker, etcd itself. We build up certificates, and then the master, the nodes, that's a typo, and the network plugins, and then any other add-ons like DNS, which is optional, but you should really use it. Helm, Prometheus, and a few others. I missed out Vault in there. If you're using Vault, it would get set up before etcd. Our component upgrade workflow is pretty simple. It's just how you would do any component upgrade in Ansible. Just change the configuration, update your launching scripts, and then restart systemd unit. Static pod upgrades for like upgrading masters would just happen by updating the config file itself. It's nothing magic.
Yeah. And on that, we do test each time so we release we tag Kubespray for when we test everything, and also we take the latest release and we deploy it on the CI and we try to upgrade to the latest commit on master. So we all the time test that the upgrade is working if you use a master, so we can keep track make sure you will be always able to upgrade your cluster.
Yeah, there's two upgrade strategies. One is the unsafe method, which just upgrades all the components, and if kubelet happens to be down for over a minute, your pods get shuffled around. But if your hosts are really fast, you might be lucky and just upgrade fine. If you have nothing in production there on your cluster, just use the default cluster YAML playbook. Otherwise, use the upgrade cluster playbook, which will upgrade masters one at a time, and then Kubernetes nodes in batches of like 20%, but that's configurable. That will shuffle your resources around, then upgrade the node, and then allow those hosts to be schedulable again. That's also me. Okay. We have HA for the two main components that need to be HA. etcd, all the clients can just connect with a comma-separated list. And the Kube API server is actually a very divisive point. We can't rely on users having like a dedicated IP for a load balancer. So kind of came up with a backwards solution, which is install a load balancer on every host, which means just run nginx locally that proxies the traffic to all the API servers. It doesn't really add much load, but it does reduce the requirement for a dedicated load balancer. But if you do have one available and you do configure it in your settings, we'll use that because it's always better when you have a dedicated load balancer. So Kubespray has been tested at scale. It's been scaled to 1,000 nodes. Deploys in about 7 hours. Ansible's kind of slow, but we still are happy with the results. The readability is definitely worth it. When you do scale Kubernetes, you do need to tweak the polling time for kubelet and make etcd nodes dedicated, just so that you have enough disk I/O for etcd to catch up. And of course, you want to run SSDs on your master components.
Yeah. Yeah, and if you're interested in the scales, there is like a couple easily find blog posts about all the details to scale 1,000 node. So what's next on Kubespray? First, like add more. So it's working on AWS, Azure, and bare metal, but we don't have like this tested in CI, which can be useful to just be able to say to checkbox it's working. One thing we want to focus also is to be able to test again master branch of Kubernetes, so be able to build Kubernetes from master and then deploy the latest, so we can actively develop on Kubernetes and just be able to deploy latest. One thing that is, I would say, missing compared to probably KOps on Amazon is auto-scaling, because right now we need to SSH, so we need like an endpoint to configure the node. And this is like really something we would like to change. So to be able to, yeah, to the node to fetch a configuration and be able to bootstrap himself. So we can just scale, point to, I don't know, a TCD or whatever to fetch a configuration. But that's like one thing really need to focus. And the different things, but also there's like a high demand for how to deploy Prometheus or Prometheus operator, the log management and different add-ons, and we try to figure out how we can do it inside Kubespray, which is compatible with the community.
Mm-hmm. Regarding this auto scaling, there is the cluster API project, which is still sort of in draft state, which seems to enable this sort of technology. You would define a change in your cluster definition, and then it would run the steps to deploy in whatever cloud you're running to create a new VM, and then run whatever deployment tool you want to put Kubernetes on it. It's kind of a vendor agnostic approach, which would be exciting, but it's not ready yet. And as always, we're looking for new contributors.
Yeah.
And thanks for coming to our talk. Do you guys have any questions? You in the green shirt.
Officially, the Docker version uses support is 17.03, which is nearly 1 year old.
Yeah, officially Kubernetes support 1.13, I think. So
No, it's supported now, 1703. So we try to keep in, the question was, why do we use 1703 in Kubespray? The answer is we keep with the recommendations of the release notes. Because if we go to a newer version, we might introduce more issues. We only upgrade as necessary when we run into bugs. The same thing goes with etcd. This is going to apply to all the deployers. So it probably will work with the latest, and we do support installing the latest version of Docker, but we default to what's recommended by the community. It's a good practice. Next.
yeah.
I was wondering if Kubespray does support multi-cloud and hybrid cloud scenarios.
So the question is like, do we support multi-cloud? So no, for now we deploy one cluster. We don't do, so we can deploy on different cloud, but Kubespray doesn't manage aggregation.
It's more of a problem of the network plugin if it'll cross the hybrid scenario. I believe Calico with IP enabled might, but I wouldn't do it.
Yep, at the back. Just, yeah.
I was asking myself how it would be possible to integrate already existing components, like if you have a remote cluster already in your company, or ETC as an example. Do you need to tweak the playbooks or the roles, or is there another way to do it?
So the question is like, can we use existing etcd or Vault?
It was done as a proof of concept. You could skip the role etcd and explicitly set the etcd endpoint variable. It did work when we tested it about a year ago, but it hasn't been repeated.
Yeah, go.
Correct.
But still, you don't move IPs around, right? Every node has its own IP, and we still direct the DNS to just one of the engines.
Let me explain that. First of all, your question is why do we do IPs change, and how does it work with a local Nginx load balancer? First of all, we don't support changing IPs of master nodes because we generate certificates based on those IPs with subject alt names. So if you change the IP, it's better to rename the node as well. In addition, we, with Ansible, create an etc hosts file with entries for every host on every node. So that's how we do DNS out of band. You back there, blue shirt.
That's me. Okay, so you mentioned between the lines that you support multi-master Kubernetes setups.
Yeah.
How well does it work, and how easy is it to do that with Kubespray?
Well, you create. The question is, do you support multi-master in Kubespray? And the answer is yes. From the first day, multi-master means first of all setting up multiple master nodes in the control plane. That's just as simple as adding your hosts in the inventory to the group kubemaster, and the point of contention is just a second. Adding connectivity to all the masters, usually 3 or 5, with a load balancer. So the local Nginx load balancer does that. It just adds all the masters in the list, and they connect.
Yeah. So to jump on this, you can really easily define the topology, like say 3 TCD, 3 master, 3 node, and on different nodes. So this is like just an inventory with groups. So you can define different nodes or use the same nodes, etc. So you can really define what kind of setup you want. So yeah.
The requirement is written that you require the nodes to have direct access to the internet. Is it also possible to incorporate some kind of proxy setup? For example, in a company, normally you don't have direct access, but you have to go to
I can answer that. Your question is, do we require proxy, or do we require direct internet access? The answer is no. Perhaps the docs are just old, but no, for every component there's a proxy support. And you can change the repo config for any Docker image as well, so you can point to your local registry, artifactory, whatever you have. Right.
We tried out the used versions of the Kubernetes stuff with the Kubespray setup before, and like there were problems, and we just changed back the configuration to the stable version and reran the playbook, so the rollback succeeded in that case. Is this something you officially support, or was it just good luck because there were no migrations done on the databases?
Question is like, can we downgrade?
Downgrades aren't officially supported, but you're very lucky.
Okay, that was basically the question. Just lucky.
Upgrades from every release to next release is guaranteed to work, but we don't actually test downgrades.
Yeah. Yeah. So the question is like, do we use Ansible Tower? So no, we have like, we never try to use Kubespray inside Ansible. Yeah, in the back. Node. So the question is like about autoscaling. So we speak about node autoscaling. So if you want to say I want one more node to manage the workload, yeah, we can do that.
I use scopes to create my cluster on the web. So what if I switch to Kubespray? What advantages I will get?
So you're using KOps and you want to know why would you change to Kubespray? This is a.
So I need to change to Kubespray, or will I have any advantages or benefits switching to Kubespray?
I mean, it depends on your use case. Usually, if you're on AWS, I would recommend and you're sure you're going to stay, for example, on AWS, I would recommend to use KOps. Usually, this is what I say. But if you want some hybrid setup, like at some point you want to be on bare metal, I would say Kubespray is much more adapted to get on multiple different cloud and notably bare metal.
In addition, there's more options in Kubespray for deployment modes. So everyone has their own personal preferences, and not even our tool offers every option possibly available, but I like to think we offer a large variety. Again? Well, so is there any revert mechanism? Not specifically, but if you were deploying from one version to another version of Kubespray, you should just go back to the previous version and see if it works.
And also in the upgrade strategy, I say it's going to upgrade one master after one other. So if you're on availability setup, different master, if one master fail, you get the other. And same when it came for the nodes, it goes like 3 node by 3 node, for example, you can set up. So, and as it drains them before. So all the pods that was running on the node, getting upgrades, they reschedule to other nodes that are live. So if these 3 get down, you still have your workload. So you can just try to reapply the upgrade, and you don't lost any availability. Like your application is still running, even if it failed in the middle of an upgrade.
The question is, can you remove or add nodes? Yes, you can add masters. No, you can add etcd nodes and cube nodes easily. Adding a master requires regenerating certs, so we don't do that automatically, but it's an option manually. So it's just a matter of modifying your Ansible inventory and running the playbook, and it will add nodes or remove nodes.
Any tips or plans on security enhancements when we are using Kubespray?
I can take that. So any tips on security enhancements? Well, in general, you make sure SSL is enabled. There is a utility that was based on some security analysis of Kubernetes. We implemented a lot of their best practices. So they're already inside of Kubespray now. So as far as I can tell, and from others, we've covered all the major security gaps that should be locked down in Kubernetes in the Kubespray project.
Yeah.
Have you ever tested or known any deployments on Azure Stack?
So question like, did we try on Azure? Yes, we have like a mini contribution on Azure. So we have like also a directory named contrib where, so we don't bootstrap node, so you need to get, but we have like in the contribution script to bootstrap on Azure, and it's been tested quite a lot on Azure. And with every, I don't know about Azure Stack, but
Yeah, we have no integration with like the automation of deploying nodes within Amazon Cloud or Azure and so on. Just you bring your own VMs, build an inventory or use dynamic inventory, and then just run the Ansible playbook. It's just for deploying Kubernetes, not bringing up VMs. That's still up to you. You have to choose a solution that works for you, because everyone wants their own.
We are setting up on-premise environment. We have to set the ingress controller, which is accessible on a certain IP. But what happens when this IP dies? I mean, when the worker dies, do you see some implementation like HA proxy with virtual IP, and behind it, for example, 2 IPs that are corresponding to the workers? Like that. To get better availability of our service.
So the question is there high availability for access to worker nodes, correct?
Yes.
No. If you want that, it sounds like you probably are more interested in bonding so that you connect your node to two switches.
Yeah, I'm seeking something like elastic load balancer in AWS. You get my point.
Yeah, but I just can't think of a scenario where one VM can't ping another VM on the same network. And you need a load balancer just to get to another node on the same network.
Yeah, we need to hit ingress, right?
Oh, ingress. Okay. So generally you set up a load balancer, yeah, for ingress.
Load balancer, and on the on-premise Kubernetes deployment, we set up a service with 1 or 2 external IPs, right?
That's still up to you because we can't manage that externally.
Yeah, but my idea was that are set up in the service for the ingress?
So this is part of the second steps, and we found like there's too many opinion about how to set up. So you speak about HA proxy and talk to someone else if we want to use traffic or Nginx. So, but at some point, like we already have many possibilities, and so we just part of the load balancing and ingress, we decided to not go on this path. You can ask questions like on the committee can help you out, but not in the main core project there.
Okay, last question, and then we should break for lunch. Okay, lunchtime. Thanks for coming.
Thanks.